as we start topic A.2, and it used to be 8.5, so sometimes that might come up. We're looking at exponential and log function. Now, what I'd like you to do is take a moment to copy this into your booklet, keeping in mind we went over this in the flipped classroom lesson as well, but this will be so important to doing these. All right, so in exponential form, we have a base that's raised to an exponent that gives us an answer. While in logarithmic form, it's log of a base that is of the answer, and this equals its exponent. Logs are exponents. So as we look at example 1, we're asked to put this, that is in log form, in exponential form. So what will our base be here? 19. What is our exponent? Well, logs equals exponents, it's 2. And that 19 to the second power squared is 361. And you're just matching it up. And there is your answer. Now, in example 2, they're giving you a logarithmic equation in a sense. It's in logarithmic form. The way to solve it is to put it in exponential form. So our base will be 9. Our exponent is x. And our answer is 9 to the negative 5. Now, one of the rules we have for exponents and logs is if your bases are the same, then the exponents equal each other. So here, x is going to be a negative 5. In example 3 now, this is in exponential form. We want to put it in log form. So what is we have to write log. What is our base? Well, our base is 8/9. We could put that in parentheses if we like. Now, what is our answer? Well, our answer is 64ths 81. And what is our exponent? Well, our exponent is 2. And we go to match this up. And it's a tad hard to see, but it's this first one. Now, they didn't put the base in parentheses, but I think that would be okay. In example 4 now, we're asked to go from logarithmic form to exponential form. So what is our base here? 256. What is our exponent? 1/2. And what is our answer? 16. And I'm going to take a moment now just to show you something, that whenever you have a base to a 1/2 exponent, think of this as the square root of 256. And it works like so. We remove our exponent for a moment, and then this becomes our radicand. Under the radical sign, 256. Now the denominator of the fractional exponent becomes our index number, which is a 2 that we don't write. I'm putting it there just to show you. Normally, if there's nothing there, it is a 2. And then the numerator is the exponent to which this is raised. So this is the fractional exponential form, and this is the equivalent radical form. So the square root of this is 16. In a sense, fractional exponents are often written as radical expressions. In example 5, we're going from, again, logarithmic form to exponential form, and then we want to find a value for x. So this would be our base is 81. Our exponent is x, and our answer is 3. Well, whenever our base is larger than the answer, we know our x value, our exponent, has to be some sort of fraction. So it's sort of like, what is the and there are a number of ways of doing this. We can think of this exponent here as the index number. And what index number would result in what power or what root of 81 to give you 3? Well, if x were a 4, the fourth root of 81 is 3. But it's not a 4 here. Remember, we said this had to be a fraction. So this would then result in, this one's challenging, this x is 1/4. Because then, putting this into its radical form, the fourth root of 81 is 3. And that is the answer. In example 6, sort of a straightforward one. It's in logarithmic form. We want to put it in exponential form. So our base is 7. Our exponent is 2. And that equals x. Well, 2 to the 7th power is 49. Example 7. Again, it's in logarithmic form. They want it in exponential form. So what is our base here? Our base is g. And what is our answer? Our answer is 6. And the exponent is 5/8. So g to the 5/8 equals 6 is this first one. In example 8 now, this ties into our work with negative exponents. But we're asked to put this just in its log form. So what is our base? Our base is 14. What is our answer? We have to put log base 14 of our answer, 1/196, equals our exponent of -2. So matching this up, it looks like this one right here. Again, if you're not sure of something, be sure you're asking questions. And to give a little more background on this before we go on, this is actually over 1, but with the negative exponent, and there's a 1 up there always, we're going to bring this negative exponent down to the denominator where the exponent changes its sign. So 14 to the second is 196. And there you can see the proof of this, but in its logarithmic form is what they're looking for. Now, for example 9, as we look at it, we want to convert it to its exponential form. So our base is 8. Our exponent is a negative 2/3. And our answer is x. So we need to simplify this. Now keep in mind that this side becomes 1 over 8 to the 2/3 power, which equals 1 over, I'm going to convert it to its radical form, the third root of 8 to the second power. Following what we've said, this becomes 1 over, the cube root of 8 is 2, 2 squared is 4. So our x value then is 1/4. And this is the protocol we followed to get to the answer. Following our protocol, we're going to convert this to its exponential form. And this one is very similar to the one we just did. So our base here is 8. Our exponent is 2/3. And our answer is x. So again, converting this exponential fraction to its radical form, we get the third root of 8, but now that to the second power. So third root of 8 is 2, 2 squared is 4. So our answer here is 4. Keep in mind that this was negative in the previous example. That's why we got the 1/4, but here we're just getting, this is in the numerator, this is 4. And these are our last two examples. Example 11, our base here is 8. Our exponent is x. And our answer is 64. Now, can we convert 64 to have a base of 8? And the answer is yes. 8 to the second is 64. So now we see, as we mentioned earlier, if our bases are the same, our exponents equal each other. So here x is 2. Or you could have looked here and said 8 to what power is 62? 8 to the second. All right. Last one. Okay, we did a lot of repetition here, but again, these were taken right from the practice which are used as certify. So hopefully showing you the protocol of how to do these. So this is its log form. What's our base? Well, our base is 6. What's our exponent? A negative 2. And what's our answer? 1 over 36. Well, again, this is its exponential form, which is this one here. But the proof of it is this becomes 1 over 6 to the second when we take that negative exponent and move it down to the denominator. And 6 to the second is 36. So 136 equals 136. All right, that'll wrap this up.